Good afternoon, everyone. My name is Samson Akomolafe. Alongside with me is my colleague Vanessa Kongolo. We are excited to present our capstone project, which is bordering about understanding crime dynamics in the United States.
Our goal was simple but ambitious to build a data-driven framework that helps policymakers understand where crime pressure is rising, what drives it, and how resources can better be allocated. So why does it matter? Why should we care? Well, crime is not evenly distributed across the country. Some states experience persistent structural pressure, while others remain relatively stable. So our method combines spatial temporal analysis, predictive modeling, and risk indexing to uncover these patterns. What's the outcome? Well, we want better resources for safety policymakers.
The source of our data is the UCR resources under FBI domain website. And we began with our EDA analysis using this UCR data from 2022 to 2024. The bar chart you're seeing on your screen show different categorical distribution of crimes, and we use that categories in our analysis.
So the scope of our analysis is threefold. One, to build a crime burden prediction model. Second, to build a state crime risk index. And third, to run an hypothesis testing. I'm going to leave it up to Samson now to talk about the crime burden prediction models.
Thank you, Vanessa. In our crime burden prediction models, we use three main modeling algorithms. First, we use lasso regression to identify the most essential predictors. Next, we use random forest to capture nonlinear interaction. And lastly, we use XGBoost to extract more nuanced offense-specific contribution. Each of these models looks at the same subject, crime burden analysis, using different lens, different perspective. And what was our result? Lasso regression gave us a clean, interpretable baseline results showing total crime and total population alone as the large driver for crime burden. Next, random forest delivered the strongest generalization performance because it has the lowest test RMSE. It highlighted aggravated assault, murder, and robbery as the most influential drivers, while XGBoost being the last model we used, even though it was less stable because of the result, yet it revealed fine-grained contribution, showing rape, burglary, and larceny theft as the drivers. Together, these three models shows that violent crime or violent offenses, especially aggravated assault and murder, are the core structural drivers of statewide crime burden. I will now invite Vanessa to treat us with the SCRI, State Crime Risk Index.
All right, thank you so much, Samson. So the State Crime Risk Index is a composite measure of relative crime risk across the United States. We integrated multiple crime categories into a single standardized index that reflects the overall crime burden experienced by a state. The way we constructed the pipeline of the SCRI was we converted the crime counts into rates per 1,000, and then we standardized the features. Next, we ran a principal component analysis to extract the features weights, and then we use those weights to calculate the weighted crime risk scores. And we normalize the score from 0 to 100, 0 lowest, 100 highest. And the final scree show that the top 5 states in terms of scree are Maryland, Louisiana, South Carolina, Georgia, and Florida. We also ran a temporal trend analysis to be able to see how the scree has been moving for the past couple of years. Turns out it actually decreased from 2022 to 2024.
As a result of the result of the test we ran, crime burden analysis, and also SCRI analysis, we came to ask a question that is very important to us. Do crime levels, do higher level of law enforcement and community resources reduce crime after controlling for population and demographics? We used joint F test and we found a statistical significant relationship. But in this case, it was in an opposite direction. The results suggest reverse casualty. High crime leads to more officers, not the other way around. Not the other way saying more officers, less crime. This aligns with real-world policy behavior, whereas resources often follow crime rather than preventing it. And also, because of this, we now use laser clustering to kind of find out if there's any association among states. We identify strong regional patterns. High crime clusters appear in the southeast and part of southwest, as you can see on the screen, whilst low crime clusters dominate the Midwest and Northeast. These spatial structures reinforce the idea that crime is shaped by regional socioeconomic condition and institutional capacity.
So in conclusion, the crime burden and analysis, the insight that came from it are that violence offenses drive state crime burden and nonlinear model reveal complex interaction. So the script provides a standardized way to compare the states when it comes to those crime. And the spatial analysis shows strong regional clustering and high crime areas pair violence with policy intensity, while low crime clusters reflect the stronger economic condition and stability.
Our data, even though had inherent limitation because of limited temporal depth and reporting inconsistencies among different states, our future work should expand SCREE inputs, use richer longitudinal data, and apply spatial panel models. But for now, we have seen that effective crime prevention requires coordinated regional strategies, investment in structural socioeconomic conditions, improve reporting consistency, and data-driven resource allocation. I will now invite Vanessa for the last concluding remarks.
All right, so Samson and I would like to thank you so much for your attention in our presentation, and would now like to open up the floor to any questions.